आपण ॲनालिटिकल आणि इंडस्ट्रियल केमिस्ट्री या पेपरमधला एक महत्त्वाचा टॉपिक लास्ट टाइम सुरुवात केलेली होती, सिंथेटिक पॉलिमर्स. ॲक्च्युअली पॉलिमर केमिस्ट्री इज वन ऑफ द इम्पॉर्टंट ब्रँच ऑफ ऑर्गॅनिक केमिस्ट्री आणि याचं आपण डिटेल डिस्कशन या टॉपिकमध्ये करणार आहोत. इंट्रोडक्शनमध्ये आपण काय पाहिलं होतं, व्हॉट इज मीन बाय पॉलिमर्स. ॲक्च्युअली पॉलिमर इज अ लार्ज molecule, it having high molecular weight, and it is generally formed by the linkage of number of small units, and that number of small units they link together, and there is a formation of a long chain compound, and that long chain compound which having high molecular weight is called polymer, while that small units are called monomer. And that process of conversion of monomer into polymer, that process is called polymerization. Okay, now in the introduction we also studied how that polymers are classified into number of types. We have studied that classification based on different modes. That means how the polymers are classified on the basis of source, then on the basis of their physical properties, on the basis of their structure, and thus on the basis of different modes how that polymers are classified. हे आपण लास्ट टाइम स्टडी केलं होतं, डिटेल क्लासिफिकेशन ऑफ पॉलिमर. नाउ लेट अस सी नेक्स्ट पॉइंट. यामधला पुढचा पॉइंट आज आपण स्टडी करतोय, थोडंसं आपण केमिस्ट्रीकडे जातोय. येस, प्रोसेस ऑफ ॲडिशन पॉलिमरायझेशन. फर्स्ट टेल मी व्हॉट इज मीन बाय ॲडिशन पॉलिमरायझेशन. आपण क्लासिफिकेशन मध्ये स्टडी केलं होतं. देर आर टू टाइप्स ऑफ द पॉलिमर. वन इज द addition and second is the condensation. What is the addition polymerization? Okay, the process in which number of molecule adds together to form a large molecule, that is polymer, and that process is called addition polymerization, and that polymer is called addition polymer. Okay, now let us see a simple example of addition polymerization. Okay, this is ethylene molecule. Ethylene molecule. When that ethene molecule is allowed to polymerize, what happens here? Number of ethene molecule participate in the reaction. Okay, I will show some molecules of ethene, second molecule, third molecule, and fourth molecule. Now here I have shown only 4 molecule, but in actual reaction number of ethene molecule participate in the reaction, and that number of ethene molecule just adds with one another, and there is a formation of long chain compound. Thus there is a formation of long chain compound, and that process is called polymerization. That long chain compound is polymer. Here the name of that particular compound is a polythene. Okay, and here that process is the addition polymerization. Now why it is addition polymerization? Because number of small molecule, number of monomers adds together to form a large compound. Therefore this is called as the addition polymerization. Let us see same reaction. Okay, here this is ethene molecule when allowed to polymerize. Okay, now instead of writing number of इथिन मॉलिक्यूल, म्हणजे इथिन मॉलिक्यूल पुन्हा पुन्हा n टाइम्स लिहिण्याच्या ऐवजी we can write simply n before that ethene molecule, means number many molecules of ethene participate in the reaction, and there is a formation of long chain compound. Now instead of writing CH2 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 for many times, we can simply write that CH2 CH2 in bracket, and at the bottom of bracket n, means that unit is repeated for many times, and this is polymer. Actually that process is addition polymerization, because here that ethene molecule undergo, number of ethene molecule undergo addition reaction to form a long chain compound, and thus number of small molecule adds to form a large molecule, that is polymer, and that process is called addition polymerization. Now here that addition polymerization can be takes place by two ways. First, by free radical mechanism, and second, ionic mechanism. Here we are going to discuss that addition polymerization in detail. Actually, how the addition polymerization occurs, what is the mechanism of this particular reaction, then what are the steps involved in the reaction, and which intermediates are formed during the reaction. Actually, that process, that addition polymerization takes place in two ways. If free radical is formed, then it is called free radical mechanism, and if the ions are formed, means cation or anion as an intermediate, then it is called ionic mechanism. Let us see first free radical mechanism for the addition polymerization. Now, what should be the free radical polymerization? Yes, if addition polymerization involve formation of free radical as an intermediate, then it is called free radical polymerization. Means during the reaction, if there is a formation of free radical as an intermediate, then it is called free radical polymerization. Generally, that reactions are carried out by using peroxide as a catalyst. Means here we are using peroxide as a catalyst. For example, it may be hydrogen peroxide, it may be some alkyl peroxide, or there may be some aromatic peroxide also. And that generally that peroxide having ability to form free radical, and then that reaction is carried out in presence of free radical. Therefore, it is free radical polymerization. Okay, now here again we have to study two different free radical polymerization. One is the free radical polymerization of alkene. Free radical polymerization of alkene, it is called vinyl polymerization. In short, it is called vinyl polymerization first. And second is the free radical polymerization of diene. Means how actually diene undergo free radical polymerization. आपण हे दोन्ही यामध्ये स्टडी करणार आहोत. म्हणजे पहिल्यांदा how the alkene undergo free radical polymerization. Alkene means simply if there is one carbon double bond. Then what is diene? If there are two double bonds. If there are two double bonds, this is diene. मग आपण यामध्ये दोन्ही एक्झाम्पल स्टडी करणार आहोत. How the alkene undergo free radical polymerization, and second, how the diene undergo free radical polymerization. Okay, now let us see one by one. First, about the free radical polymerization shown by alkene. Actually, by using this method, we can synthesize the different polymers like polythene, polyvinyl chloride, that is PVC, or by polyacrylonitrile, polyvinyl acetate, etc. by using that free radical polymerization of alkene. Actually, that polymerization takes place in 3 steps. There are 3 steps involved in that type of polymerization. One is the chain initiation, then second is the chain propagation, and third one is the chain termination. Okay, now we have to study that reaction in detail, how the chain initiation, propagation, and chain termination occurs in the polymerization of alkene. Okay, let us see simple example of alkene. First step is the chain initiation. In first step, what happens in the free radical polymerization? There is a use of peroxide. Peroxide act as an initiator. तो reaction ची सुरुवात करतो. Therefore, it is called initiator. And now in the first step, that peroxide undergo decomposition. It undergo decomposition. Let us see how the peroxide undergo decomposition. This is just peroxide R, C double bond O, O, again oxygen. There is a covalent bond between that two oxygen. This is actually peroxide. We can use hydrogen peroxide also. In first step, what happens? That peroxide undergo decomposition. It undergo homolytic bond breaking. Here, the bond between that two oxygen atom, it undergo homolytic breaking. Means one electron from the shared pair goes towards one oxygen atom, while second electron from the bond goes towards second oxygen atom. Means there is a homolytic bond breaking. Now that oxygen acquires unpaired electron, second oxygen also having unpaired electron, and thus I can simply write twice R, C double bond O, and O, it having unpaired electron. And we know that if any species having unpaired electron, then that species is called free radical, and thus there is a formation of free radical. Just peroxide undergo decomposition. There is homolytic bond breaking, and we get the free radical. But this free radical again undergo decomposition. How it undergo decomposition? This bond undergo breaking. Yeah, bonds breaking hota. One electron goes towards carbon, and second electron goes towards R group, means towards alkyl group. Okay, now here it again homolytic bond breaking. There is homolytic bond breaking. One electron goes towards carbon, second electron goes towards R, means alkyl group we can say, and there is a formation of R having unpaired electron. Actually, there are two molecules, hence I have written twice. Okay, now that R having unpaired electron, this is again free radical. This is again free radical. Now, what should be the byproduct? Now, there is one electron from this bond, that one electron from the carbon, and one electron from the oxygen. There is a formation of pi bond between two atoms. means C double bond O, C double bond O, means there is a carbon dioxide. I have directly written CO2. Now in the next step, what happens? This free radical adds to our alkene monomer. It adds to, what is the monomer here? We are using alkene. Okay, now this free radical adds to the alkene and we get a new free radical. Let us see next step in the chain initiation. Okay, this is our free radical which is formed in the first step. Okay, now it reacts with our alkene. Suppose we are taking the example of the simple alkene ethene molecule. आपण simple alkeneचं example घेऊया, ethene molecule. Now this free radical adds to that alkene. म्हणजे reaction कशी होते? Here this pi bond undergo breaking. There is also homolytic bond breaking. Okay, one electron goes towards carbon and second electron goes towards another carbon. Okay, now both the carbon having unpaired electron. Now this unpaired electron of R group and unpaired electron of carbon, there is a formation of covalent bond between R and carbon. या R जवळचा अनपेड इलेक्ट्रॉन आणि कार्बन कडे असणारा अनपेड इलेक्ट्रॉन दोन्ही मध्ये इलेक्ट्रॉनची शेअरिंग होते. देयर इज अ फॉर्मेशन ऑफ कोवलंट बॉन्ड बिटवीन दैट R and carbon. We get the next species. This is the next species. Now this is a new bond between R and carbon. While that last carbon having unpaired electron, means again there is a formation of free radical. Again there is formation of free radical, and suppose this is new free radical, and that step is called chain initiation. Now what happens in the chain initiation? In chain initiation, first step, that peroxide undergo decomposition. We get the free radical. This free radical further adds to the alkene molecule, and this pi bond undergo breaking. There is homolytic bond breaking, and we get the new free radical. Here that carbon having unpaired electron. This is the first step, chain initiation. Now in the second step, what happens? This is the chain propagation. This new free radical again adds with another alkene molecule. Okay, now let us see how that new free radical adds to another alkene molecule. This is the new free radical which is formed in the chain initiation step. It further reacts with another alkene molecule, means another ethene molecule, second ethene molecule. Here also same type of bond breaking occurs. Same type of addition occurs. How the pi bond undergo breaking? Yes, there is homolytic bond breaking. One electron goes towards carbon, second electron goes towards another carbon. Now this electron of carbon and unpaired electron of this carbon, there is a formation of bond between these two. या दोन्हीच्या मध्ये bond formation होतं, addition होते दोन्हीची, and we get the species. आणि मग species आपल्याला कशी मिळेल बघा. This is the new bond actually. This is the new bond. While that final carbon having unpaired electron, and thus new free radical further react with the next molecule of ethene, and there is a formation of new free radical. Again, this is the large free radical. I can say large free radical. There is a formation of large free radical. Okay, in this way, now this large free radical again react with the next ethene molecule. Okay, let us see how it reacts. Okay, it reacts with the next free radical. Again, the same type of reaction occurs. Means how it adds to that carbon double bond carbon. म्हणजे इथला bond break होतो. One electron goes towards carbon. Second electron goes towards this carbon. Now there is a formation of bond between this carbon and this carbon of free radical. Okay, and we get another species. In this way, I can say in this way, number of ethene molecule adds continuously. Number of molecule, ethene molecule, alkene molecule adds continuously to the free radical, and we get a long chain free radical. There is a formation of a very large free radical, and this is the very large free radical. And actually in this reaction I can say n number of ethene molecule participate, and there is a formation of a very long chain compound. मग इथं आपण long chain compound सुद्धा लिहू शकत नाहीये, म्हणून मी ब्रॅकेट दाखवलेला आहे. At the bottom of bracket there is N, means many times that unit is repeated. म्हणजे CH2 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 म्हणजे हे युनिट पुन्हा पुन्हा रिपीट होतं. And at the terminal carbon there is unpaired electron. Thus there is a formation of a very large free radical. मग खूप मोठा free radical या ठिकाणी तयार होतो, and that addition continuously until a very large free radical is formed. This is about the chain propagation. Okay, last step is the chain termination. Termination म्हणजे ही चेन कुठेतरी थांबायला पाहिजे. मग कुठे थांबते? When that free radical combines together. हे फ्री रॅडिकल ज्यावेळेस एकमेकाबरोबर कंबाईन होतात, मग कंबाईन झालं की फ्री रेडिकलची संख्या कमी झालं की चेन रिॲक्शन थांबते. मग लेट अस सी हाऊ द टर्मिनेशन ऑकर्स. ओके, दिस इज अवर लार्ज फ्री रेडिकल RCH2, CH2, CH2, then CH2, CH2 n times, and at the end there is CH2 having unpaired electron. Okay, this is our large free radical which is formed in the chain propagation. Now this free radical can be combined with simple alkyl free radical. हा अनपेड इलेक्ट्रॉन आणि याकडे असणारा अनपेड इलेक्ट्रॉन यामध्ये कोव्हलंट बॉन्डचं फॉर्मेशन होतं. म्हणजे देर इज शेअरिंग ऑफ इलेक्ट्रॉन, देर इज शेअरिंग ऑफ इलेक्ट्रॉन अँड जस्ट देर इज फॉर्मेशन ऑफ सिंपल सिग्मा बॉन्ड अँड वी गेट द लॉंग चेन कंपाउंड. देर इज दिस इज द न्यू बॉन्ड बिटवीन कार्बन अँड R group and there is a formation of a very large molecule which having number of monomers is linked together and that is called as the polymer. याला आपण polymer असं म्हणतो. This is the chain termination. Okay, that free radical can be combined with one another and there is the formation of long chain compound and thus this is nothing but the polymer. Now there is one more way. यामध्ये termination मध्ये आणखीन एक प्रकार आहे. मी मगाशीचा फ्री रेडिकल पुन्हा एकदा दाखवतो. दिस इज अवर लार्ज फ्री रेडिकल at the end carbon having unpaired electron. Now that large free radical, one large free radical can be combined with another large free radical. म्हणजे याची रिॲक्शन आणखीन एका लार्ज फ्री रेडिकल बरोबर होऊ शकते. दिस इज अनदर फ्री रेडिकल. Now what happens? That's unpaired electron. This unpaired electron, they form sharing of electron and there is formation of sigma bond and we get a long chain compound and this is the long chain compound. This is the long chain compound, very long chain compound and this is the new bond formed between that two carbon. Sigma bond formed between two carbon and we get a long chain polymer and this is the just a mechanism for the free radical polymerization of alkene. We have studied how the alkenes undergo polymerization. Actually, this is the free radical mechanism. There is a formation of free radical as an intermediate. We have studied how actually that process occurs. Actually, there are three steps: chain initiation, propagation, and termination. And we get a long chain compound. Let us see next one. Free radical polymerization of diene. We have studied the example of alkene. Let us see example of diene. Diene which having two double bonds. Okay, let us see simple example of diene. Yes, CH2 double bond CH, CH again double bond CH2. What is the name of diene? Yes, it is 1,3-butadiene. Very simple and very interesting example of diene. 1,3-butadiene. It is example of conjugated molecule. Okay, now let us see how that butadiene undergo polymerization. Here it undergo free radical addition polymerization. Actually, that polymerization takes place through the formation of free radical and it is initiated by peroxide. Means here also catalyst is the peroxide and that reactions are initiated by the peroxide. Okay, and there are again following different steps of that polymerization: chain initiation and chain propagation. Let us see that steps, how the polymerization occurs. Actually, first step is the safe. We are using peroxide. Peroxide act as an initiator. Now what happens here? Yes, first step in chain initiation, it undergo decomposition and gives a free radical. Okay, let us see same type of decomposition is here. Here this is peroxide. In first step, this bond undergo homolytic breaking. One electron goes towards oxygen, second electron goes towards another oxygen atom, both the oxygen having unpaired electron and there is a formation of free radical. This is quite unstable. Therefore again undergo decomposition. It's a puna decomposition होतं. Here this bond undergo breaking. One electron goes towards carbon, second electron goes towards alkyl group. Now alkyl group acquires unpaired electron. Yes, alkyl group acquire unpaired electron. Now this unpaired electron of carbon and unpaired electron of oxygen form double bond between C and O. Thus there is formation of CO2, carbon dioxide. Byproduct is carbon dioxide and we get the free radical. This is the first step. Now let us see what is the next step. Now this free radical further adds to the 1,3-butadiene. Now this free radical adds to 1,3-butadiene in two ways. This is our free radical. Okay, it adds to the butadiene. This is 1,3-butadiene. Now here what happens in that step? In presence of that free radical, the bond between that two carbon atom, pi bond between these two carbon atoms, it undergo breaking. There is a homolytic bond breaking. There is a breaking of that pi bond. Okay, one electron goes towards carbon, second electron goes towards another carbon. Now that unpaired electron and this electron from the carbon form a bond between R and carbon, and we get the another species. This is the new bond between R and carbon. While that central carbon now having unpaired electron, this pi bond as it is, this double bond as it is, and there is a formation of new free radical. Okay, this is the first way. Now this is the first way. Now there is one more method for the addition. Let us see that second method. Okay, same type of the free radical is there. Now it react with the 1,3-butadiene. This is our 1,3-butadiene. Now what happens in the second way? What happens in the second way? Yes, here also that pi bond undergo breaking. This is homolytic bond breaking. Right, one electron goes towards carbon, second electron goes towards again carbon. Similarly, similar to that pi bond, this another bond also undergo breaking. That pi bond also undergo breaking. One electron goes towards carbon, second electron goes towards this carbon. This electron, one electron of this carbon and one electron of this carbon, they share to form a pi bond between these two carbon. या दोन सेंट्रल कार्बन मध्ये नवीन pi bondचं फॉर्मेशन होतं. याच्यावरचा एक अनपेड इलेक्ट्रॉन, इथला एक, आणि यावरचा एक इलेक्ट्रॉन. देयर इज sharing of electron and we get a new pi bond between these two carbon, while that carbon having unpaired electron, this carbon having unpaired electron. Now again this electron and electron from the carbon, it form again new bond between that carbon and R group. बघा इथं नवीन बॉन्ड कुठे तयार होतोय? दिस इज द न्यू बॉन्ड. दिस इज द न्यू बॉन्ड म्हणजे इथला कार्बन आणि R ग्रुप यामध्ये नवीन बॉन्डचं फॉर्मेशन होतं. इथला डबल बॉन्ड ब्रेक होतोय, ओनली सिंगल बॉन्ड. हिअर देयर इज फॉर्मेशन ऑफ न्यू बॉन्ड. इथं नवीन पाय बॉन्ड तयार झाला, हा सुद्धा बॉन्ड ब्रेक होतोय. दॅट इलेक्ट्रॉन गोज टुवर्ड्स अनदर कार्बन, मीन्स हिअर देयर इज अनपेड इलेक्ट्रॉन and thus we get the free radical. But what is the difference between that first and second free radical? In first and second free radical, addition takes place in different manner. Addition takes place in different manner. या वरच्यामध्ये there is a breaking of only one pi bond, but in second there is a breaking of two different pi bond. दोन वेगवेगळे pi bond break होतात and formation of new pi bond is also there. This is called as the secondary free radical. This is secondary free radical, while that second is called primary free radical, because here unpaired electron is on terminal carbon. Therefore it is primary, and this one is the secondary free radical. And thus in a chain initiation, peroxide undergo decomposition and we get the free radical. That free radical adds to the 1,3-butadiene in two different ways. That free radical adds to the 1,3-butadiene in two different ways, and we get the primary and secondary free radical. This is the chain initiation. Now let us see next is the chain propagation. Okay, let us see example of secondary free radical. This is secondary free radical further react with the another molecule of 1,3-butadiene. This is the another molecule of 1,3-butadiene. Okay, now here what happens? This bond pi bond undergo breaking. यामध्ये सुद्धा addition होते free radical ची, याला या pi bond ची breaking होते. Here this pi bond undergo breaking. One electron goes towards carbon, second electron goes towards this carbon, and there is a formation of actually this unpaired electron form. There is just sharing of electron and form a sigma bond between this carbon and this CH2. या CH आणि CH2 मध्ये नवीन बॉन्डचं फॉर्मेशन होतं. हा pi bond break होतो and electron pair goes towards carbon. It acquires just unpaired electron, and thus there is unpaired electron on this carbon, and this is the new bond. हा नवीन बॉन्ड असेल, या दोन्हीच्या मध्ये नवीन बॉन्डचं फॉर्मेशन असेल. खालचं जे CH डबल बॉन्ड CH2 ऍज इट इज मी दाखवलेला आहे, अँड दिस इज द न्यू बॉन्ड. हा नवीन बॉन्ड असेल आणि इथं आता अनपेअर्ड इलेक्ट्रॉन येतोय, अँड दिस वी गेट द न्यू फ्री रॅडिकल, आणि आपल्याला हा नवीन फ्री रॅडिकल या ठिकाणी मिळतोय. ओके, म्हणजे पहिल्या स्टेप मध्ये फर्स्ट इनिशिएशन मध्ये जो फ्री रॅडिकल तयार होतो, दॅट फ्री रॅडिकल फर्दर रिएक्ट विथ द 1,3-butadiene. That is secondary free radical which react with the 1,3-butadiene, and we get another large free radical. Now this large free radical further react with the n number of butadiene molecule. Now how the addition occur? Yes, addition occurs in the same way. त्याच पद्धतीने ऍडिशन होते. म्हणजे कशी ऍडिशन होते बघा, हिअर दॅट कार्बन, हा जो कार्बन आहे इट फॉर्म अ बॉन्ड विथ दिस कार्बन, याच्याबरोबर बॉन्ड तयार होतो. आणि हा जो CH डबल बॉन्ड CH2 आहे तर आपल्याला खाली दाखवावं लागेल. या दोन्हीच्या मध्ये नवीन बॉन्डचं फॉर्मेशन होतं. हा बॉन्ड ब्रेक होतो. यामधली एक अनपेअर्ड इलेक्ट्रॉन या कार्बनकडे जाते अँड वी गेट द ओके. इथं मी इलेक्ट्रॉन पेअर दाखवले अँड नंबर ऑफ टाइम्स दॅट ऍडिशन टेक्स प्लेस. खूप वेळा असे ऍडिशन होते म्हणून मी डायरेक्टली काय दाखवलेलं आहे, हिअर देर इज अ ब्रॅकेट अँड ॲट द ब्रॅकेट bottom of bracket there is n time, means this unit is repeated for many times and we get a very long chain compound and that long chain compound having unpaired electron on the secondary carbon and thus there is a formation of long chain compound. Actually this long chain compound can be combined with another free radical to form a long chain polymer. This is the chain propagation for the secondary free radical. This is for the secondary free radical. In the chain initiation we have studied there is a formation of two types of the free radical. One is the secondary and one is the primary. आपण आता काय बघितलं, how the secondary free radical further adds with the butadiene and there is a formation of long chain compound आणि आपल्याला पॉलिमर कसा मिळतो हे आपण त्यामध्ये पाहिलं. लेट अस सी चेन प्रोपगेशन फॉर द प्रायमरी. आपण प्रायमरी साठी बघूया. ओके, दिस इज आवर प्रायमरी फ्री रॅडिकल विच इज फॉर्म इन द इट इज फॉर्म इन द फर्स्ट स्टेप. ओके, इट फर्दर रिॲक्ट विथ द ब्युटॅडाईन. त्याची पुन्हा रिॲक्शन ब्युटॅडाईन बरोबर होते. मग इथं रिॲक्शन कशी होते, there is a breaking of some pi bond. Pi bondचं ब्रेकिंग होतं बघा. there is homolytic bond breaking. One electron goes towards carbon, second electron goes towards carbon. Similarly that pi bond also undergo breaking. One electron goes towards carbon, second electron goes towards carbon. Okay, now what happens, this carbon, या कार्बनवर असणारी अनपेड इलेक्ट्रॉन, दॅट अनपेड इलेक्ट्रॉन आणि इथल्या कार्बनवरची अनपेड इलेक्ट्रॉन या दोन्हीच्या मध्ये नवीन बॉन्डचं फॉर्मेशन होतं. शेअरिंग ऑफ इलेक्ट्रॉन इज देअर. आणि त्याचबरोबर या कार्बनवरचा अनपेड इलेक्ट्रॉन आणि इथल्या कार्बनवरचा अनपेड इलेक्ट्रॉन या दोन्हीच्या मध्ये पायबॉन्डचं फॉर्मेशन होतं. इथं पायबॉन्ड तयार होतो, नवीन पायबॉन्ड, आणि इथला अनपेड इलेक्ट्रॉन याच्यावरती जातो, इट हॅव्हिंग अनपेड इलेक्ट्रॉन. ओके, दॅट्स देयर इज फॉर्मेशन ऑफ लार्ज नेक्स्ट मॉलिक्यूल. म्हणजे सिंपली तुम्ही असं म्हणा, इथं दोन्हीच्या मध्ये नवीन बॉन्डचं फॉर्मेशन, त्यानंतर इथं जो आहे अनपेड इलेक्ट्रॉन आणि इथला अनपेड इलेक्ट्रॉन, दोन्हीच्या मध्ये पाय बॉन्ड आणि एक इलेक्ट्रॉन इथं गेल्यामुळं इट ॲक्वायर अनपेड इलेक्ट्रॉन. बरोबर, म्हणजे इथं डबल बॉन्ड ॲज इट इज आहे. ओके, दिस इज न्यू बॉन्ड. हा आपला नवीन बॉन्ड असेल आणि इथला जो पाय बॉन्ड आहे तो सुद्धा नवीन असेल, यामधला एक पाय बॉन्ड नवीन असेल. ओके, दिस इज जस्ट अबाउट द फॉर्मेशन ऑफ न्यू फ्री रॅडिकल. या पद्धतीनं न्यू फ्री रॅडिकल तयार होतो. इट फर्दर रिॲक्ट विथ अनदर मॉलिक्यूल. त्याची रिॲक्शन पुन्हा नवीन मॉलिक्यूल बरोबर होते, त्याच पद्धतीने ऍडिशन होते आणि या पद्धतीने आपल्याला लॉंग चेन कंपाऊंड मिळतो. मी इथं ब्रॅकेटच्या बाहेर n टाइम्स असं मेन्शन केलेलं आहे. मीन्स दॅट युनिट इज रिपीटेड फॉर मेनी टाइम्स अँड वी गेट अ लॉंग चेन कंपाऊंड. दिस इज अगेन चेन प्रोपगेशन अँड वी गेट द अ लॉंग चेन पॉलिमर. Okay, this is just about the free radical polymerization.